put parentheses if needed. And now I want to solve. So to solve, I'm going to add 1/2 to both sides. So I'm going to have 2, and I'm going to add a half. Well, I need a common denominator, so I'm going to write 2 as 4/2. And I'll say that 1/3 of x will equal 5/2. Now, to get this by itself, the x by itself, we'll multiply both sides by 3, and we'll be left with x equaling. Now remember, to multiply a fraction times 3, you think of this as the fraction 3 over 1. 3 is the number 3 over 1. Now we multiply the numerators, and we come up with 15. Multiply the denominators, and we get 2, and x equals 15/2. Okay, so just a good reminder on how to deal with fractions when they're in a problem, and it's okay to do that. In fact, I prefer fractions, because then I don't have to be punched on my calculator and maybe get a decimal, and what is the decimal really coming from. So when I'm at the board, I'll always do fractions. 20 gives you a statement that has v equals, I think it's xy plus yz plus xz, and it says solve for y. So the first thing we want to do is we want to look in here and say, well, where are my y's? There's 2 y's. So this means that v minus xz equals xy plus yz. Now, what I've now done is the terms that have y's I've isolated on one side. The terms without y's are on the other side. And let's go ahead. Ooh, how can I get that y by itself? Undistribute. Okay? These both have a y in common, so that's y times the quantity of x plus z. Now, if I distribute that, that's xy. All right? That is z times y, so yz. And that equals v minus xz. Now, I'm multiplying y by this, so I'll divide it by that. And there's going to be my answer. Sorry, I didn't quite leave enough room. We'll sneak it in right here. V minus xz divided by x plus z equals y. Okay? Yeah. So there you have your solved for y in number 20. Okay, there's a couple of them. 27, 4x cubed minus 500 is 0. Again, this is already set equal to 0, so I'd like to be able to factor here, but in this case I only see one variable, this x right here, raised to a power, so I can isolate it as long as I deal with multiple roots, okay? And so we're going to try that, we'll call this 4x cubed equals 500. Now, the key here is I need to first isolate the x. I need to say it's x to some power, and then I can undo it before I try to take a cubed root. So I'll divide by 4, and x cubed will be equal to, I believe that's going to be 250, 125. And now, how to undo cubing something is to raise it to the 1/3 power. Power to a power is multiplying. That's x to the 3 times 1/3. That's going to be x to the 1st. And that will equal 125, it's 1/3. Now, cube roots. Let's see, cube roots. Can I get negatives? Do I need a plus or minus here? No. It's an odd root, so the sign is taken care of in here, and that will be 5. You can ask your calculator what's 125 raised to the 1/3, or you can ask your calculator what's the cube root of 125, or you can ask yourself, what times itself 3 times is 125? 5 times 5 times 5? Yeah, it's 5. Okay? So one of those hopefully will help you in finding that cube root. And then of course check. 5 cubes is 125, times 4 is 500, minus 500 is 0. Use your calculator, you can check. Okay, 39. We're going to get into some problems here where we have a fractional equation, but I have in the denominator is my variable. Whenever that happens, I want to get it out of the denominator, but first maybe we should combine this side into one denominator, and then I can get it out of the denominator. So I will multiply this by the magic number 1, that's x over x, and I chose that because that was the denominator here. I will multiply this fraction by the quantity of x minus 1 over x minus 1. And I chose that because it was over there. But notice, x minus 1 over x minus 1 should be 1. So I'm multiplying this fraction by 1. It shouldn't change it. But this new numerator will be x minus 1 plus, nice that it's an addition sign. And that one over there will be 2 times x. And now they had a common denominator of an x in red. And well, I guess we can do this, I'll just do that in red. X and x minus 1 were the denominators, and that will equal 3. Now at this point I want to clean up this numerator, and so x minus 1 plus 2x is 3x minus 1 over x times the quantity of x minus 1, and that's supposed to equal 3. Now I can get to the point where here's my denominator, and it has the x's in it. So I am going to multiply both sides by that x times x minus 1. Because remember, if two things are equal, and I multiply by the same thing on both sides, they should stay equal. In this case, those will be gone, but on that side it won't. And I'll be left with 3x minus 1 equals 3 times x minus 1. So I'm going to put x squared, we'll go with this. Okay? And then we'll sneak this up here. So now this is telling me that 3x minus 1 is equal to 3x squared minus 3x. It'd be nice to get that all on one side, so I'll keep it on that side. We'll subtract the 3x, we'll add a 1 to both sides, and we'll get that 0 is 3x squared minus 6x plus 1. Now, I have a quadratic set equal to 0. We should have some tools in our tool belt on how to solve this. You can use completing the square, quadratic formula, or factoring. Okay? And I'm going to see this as factoring right now. Well, maybe not. Maybe not. I'm going to see this as quadratic formula. X equals positive 6 plus or minus the square root of negative 6 squared plus negative 4 times 3 times 1 over 2 times 3. That's going to be 6 over 6, so it's going to be 6 plus or minus the square root, and I'm going to take a shortcut here. 36 minus 12 is 24 over 6. All right. So, sorry about the board magic. The board, I did not put this up here high enough. I got space here. X equals 1 plus or minus, let's see. Square root of 24 is 4 times 6. That's 2 times the square root of 6. That's 2 over 6. So 2 times the square root of 6 over 6, which really is 1 plus or minus the square root of 6 over 3. Oh, that's poorly board managed, but there is the exact answer for that problem. Remember, exact answers do not have decimals. You leave them in fractional form. You don't go to your calculator and figure that out. You leave it there. Okay, let's see if I have time for my other problems here. Oh, I got a few of them. 41, x to the fourth minus 8x squared minus 9 is 0. I might have to speed this up a little bit. So, here we go. X to the fourth minus 8x squared minus 9 equals 0. Okay? Well, I can see this as a factorial problem, and this is x squared. Okay? And we're going to go with a minus 9 there, and an x squared plus 1 is 0. Notice x squared times x squared is x to the fourth, so I see this just like a quadratic, where I can either factor it, use the quadratic formula, or complete the square. The key here, the difference is that even after I get what this x squared is, because this x squared can equal 9, right? Or that x squared can equal negative 1, I can solve again. X squared is 9 when x is plus or minus 3. X squared is negative 1 when x is plus or minus the square root of negative 1, otherwise defined as I. So make sure we get all of those answers. You could factor the x squared minus 9 again, but you'll have a hard time factoring the other one, so make sure you remember your pluses or minuses there. All right. Let's see where else we want to go here. 49. You know what? I'm going to skip that one. Maybe I'll come back to it. 75. 3x minus 2 is greater than negative 11. Nope, we're going to go right to 83. Timing-wise, 83, we look at that when we say x minus 4 over x squared minus 4, and here's the key on this one, is less than or equal to 0. Okay? Because before I got to that point, I was thinking, oh, this is problems just like before. Okay, I'm just going to, well, wait a second, I can't do the same things that I was going to do before because this is an inequality. So because this is an inequality, we want our key numbers when it's undefined. Because I'm going to think of graphing this and see when our truth statements will change. Okay? So I'm just going to figure, when it's undefined is when x squared minus 4 will equal 0. When that denominator turns out to be 0, we're going to have troubles. And that's going to happen when x squared is positive 4. So when x is plus or minus 2. Okay, so there are some key numbers when it's undefined. We also have a key number when it's equal. When x minus 4 over x squared minus 4 equals 0. Well, when a fraction is equal to 0 is when the numerator is 0. Granted, the denominator can't be. That happens when x is 4. Will 4 make the denominator 0? No. So I have 3 key numbers here. And that was what was my first job, was to figure out where these key numbers are. This one's at 4. This one's at 2. And this one's over here at negative 2. So we need to introduce another color. Because it's an inequality problem, now I need to check the regions. These key numbers have split it into 4 regions. I need to check something less than negative 2. So I'm going to check negative 3. I'm going to check something here. 0 is good. Better check positive 3, and we'll check 5. You might say, what do you mean by check these? I mean, I'm going to go back to the original and see if it makes the sentence true or false. So I put negative 3 into that original. Negative 3 minus 4 is negative 7. Negative 3 squared is 9. 9 minus 4 is 5. Is that less than or equal to 0? And the answer is yes. When I check 0, I get negative 4 over negative 4. Is that less than or equal to 0? And that answer is no, that's 1. 1 is not less than or equal to 0, so that answer is no. When I check 3, 3 minus 4 is negative 1 over 9 minus 4. Is that less than or equal to 0? And that answer is yes. Okay, and I check 5. 5 minus 4 is 1. 5 squared is 25 minus 4. Is that less than or equal to 0? And that answer is no. Now some of you might think, well, geez, these are always just going to alternate. Oh, no, 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 no. They're not always going to alternate. You need to check all of those and see the numbers that we have. And this is me kind of taking shortcuts, but at least I know for sure what I'm checking. You might want to put that in a grid, but you need to show me that you're checking those numbers in the original to see those numbers turn out. Because now, this will tell me that my answers are the things that are in here. So negative 2, that was because it was undefined. That's an open circle, and it's those things. 2 was also undefined. That's an open circle. 4 was exactly equal. So we have this right here. These are numbers x's that are strictly less than negative 2. These are starting at 2 and less than or equal to 4. There are my regions for those answers. Okay? I don't know if I have time. I'm going to try to squeeze one more in here. 87. And I'll have to leave the rest for questions in class, in your groups, or in class, or to your teacher. 87. Absolute value of 2x plus 1 is supposed to be greater than or equal to 1. Okay. Remember, I need the same idea here. I need key where it's undefined or key where it's equal. Well, key undefined, the key numbers where this statement is undefined, there is none. It's an absolute value. You can always plug it in, get an answer, take its absolute value. So there's none of those. But for key being equal, that's when we have the absolute value of 2x plus 1 equals 1. That happens when 2x plus 1, that stuff in there equaled 1. Or if the stuff in there was negative 1, then we take its absolute value and it turns into positive 1 anyways. So here's my situations. So I'll subtract 1 from both sides, and I'll get that 2x is 0, therefore x is 0. Over here I subtract 1 from both sides. Be careful. Don't get into the trap. It's the same thing, because that's going to be negative 2. X will be negative 1. And again, I want to solve this inequality, so I'll go here and I'll check. I have one at 0. Oops. I want to switch that around. We're going to call that one negative 1. We're going to call that one 0. And now I need to check. What should I check? I should check negative 2. I should check negative 1/2. And I should check 5. Let's see. Negative 2. 2 times negative 2, negative 4 plus 1 is negative 3. Is it absolute value greater than or equal to 1? And that answer is yes. Negative 1/2 times 2 is negative 1. Negative 1 plus 1 is 0. Is 0 greater than or equal to 1? That answer is no. Check 5. Is 11, the absolute value, greater than or equal to 1? The answer is yes. Isn't that nice that it did this to us for us again? So at negative 1, it will be closed because this is a less than or equal to. So at negative 1 to there, and from 0 and up to here. We need to list this as two different regions. X is less than or equal to negative 1, comma, x is greater than or equal to 0. You can't put this as one